Hello everyone. Now welcome to my presentation. My name is Shivam Singh. I am a student of BTech at Gnsu. I am going to represent my PPT under guideline my faculty of Dr. Rajkumar mondal. Now welcome to my presentation. Node analysis for DC circuit and introduction. Identify node in the circuit. Apply Kirchhoff current law of KVL. Each node express the content in terms of voltages. A set of the node equations. Node analysis for DC circuit. Node analysis is a method of used to solve electrical circuit by determining the voltage at each node relative to a reference nodes. In DC circuit, this method is particularly used for solving current that in voltage restore. Current source and voltage source the ideal of equation based on Kirchhoff current law, which state of that the sum of current entering at node must equal to sum of current leaving nodes. The identity nodes in the circuit. Identity or all nodes in the circuit where component connect nodes in a point where two or more circuit element meet. Choose the reference nodes, also known as the ground nodes. It is usual make as OV, 0V voltage, and all the nodes are voltage in will be measured reactive to it. Label the remaining nodes with unknown voltage. Example V1, V2. Kirchhoff apply Kirchhoff current law KCL at each node. KCL states that the sum of current flowing into a node is equal to the sum of current flowing out the nodes. For each non-reference node, write as equation of base of KCL. Express the current of voltage. Express the current of voltage is I equal to V1 minus V2 by R, where V1 and V2 are of the voltage of two ended of resistance. R is this resistance for a node of multiple resistor, and the circuit of entering on leaving the nodes of can be expressed at the voltage difference across the resistor divided in by resistance. Set up the node equation. For each node apply KCL by summing the current of leaving nodes and set up the equal to 0. Each current expressed as the voltage difference divided by resistance as the show of Ohm's law. Solve the equation. After setting the KCL equation for all nodes, you will have the system of systematic equation. Solve these equation using methods such as the solution and or matrix method. Examples problem. Consider a simple DC circuit with three resistors, a voltage of source, and two nodes. Resistors R1 connect nodes in 1 to ground. Resistors second R2 connect the node 1 to node 2. Resistor R3 connect the node 2 to ground. A voltage source Vs connect a node to ground. Circuit be analyzed as following. Level 1. Let nodes 1 V1 and V2 ground into at the 0. Write KCL equation. Node 1 The current through R1 equal to V1 minus 0 by R2. R1. The current through R2 V1 minus V2 by R2, and the circuit of voltage source is Vs minus V1 by R1. By KCL, the sum of current leaving node 1 is 0. V1 by R1 plus V1 minus V2 by R2 equal to 0. Node 2. The current R3 equal to V2 by V3, and the circuit through R2 V2 minus V3 by R2, and the equation of V2 by V3 R3 plus V2 minus V1 by R2 equal to 0. Solve the equation. I can solve these two equations for the voltage of V1 and V2. General statement for node analysis: identify the number of nodes, count all the nodes in the circuit, and assess voltage variable to each node concept to reference nodes. Apply KCL. For each non-reference node, write the current balance equation for using Ohm's law for the circuit through at component of connected to the nodes. Set of equation. Express each KCL equation as a layer of equation in terms of the node voltage. Solve the system. Solve the equation of systematic equation or to find the unknown voltage. The method will be well current of multiple resistors, and the sources are the current. Now thank you for my presentation.